Okay, let's get to the fun part of sets. This is something we will see a lot in discrete math. Let's look at the example where we have two sets, and we're going to look at the union of these two sets, and we will have two options. We will have to, for example, return a set that has the values that is a union of two sets, or convert one set as union of two sets. So let's go ahead and put up the sets anyway. So set 1, and let's make it equal to a bunch of numbers, 1, 2, 3, 4. All right? So let's go ahead and have another set, set 2, and let's put some numbers in there. So we'll go ahead and put 2, 9, 5, 5, and 6. Okay. So we notice that we have a common value here, and then all of these values are distinct. So now, let's go ahead and return to a set the union of these two. So let's go ahead and create set 3, and we're going to make it where it will be the union of set 1 and set 2. And that will be equal to set 1 dot, and as you can see here, so if I type the letter U, I get to union as a method, so I can pick that. But then as an argument, you need to supply the other set. So that would be set 2. All right, so let's go ahead and print set 3 and see what the result is. Okay, all right, let's run this. And there you have it. 1, 2, 3, 4, 5, 6, and 9. Notice that duplicates will only be used once. So that's particular characteristic of a union. Okay, now let's look at another way to do this. And we're going to do this with the update method. By the way, if you want to follow along which methods I'm going to be using in the order that I'm going to be using, they're all listed here as comments. So these are what we call the joining sets, and these are the methodologies where we're going to look at the union and the intersection of sets. Okay. All right. So now let's go ahead and So by the way, if you print set 1 and then put set 1 here, you will notice that nothing happened to set 1 and set 2 at this stage. So print set 2, and let's go ahead and put quotes here. So, and basically this print function has two arguments, set 2, and this one here we'll put set 3 equal. And let's see what the result is in here. You could see here that set 3 is a combination of all of them. Set 1 is still set 1 the way we set it up, so is set 2. Now, by contrast, if we use update, what would happen, and how to use update? So to update, you're going to have to take it back or update an existing set. Okay? So let's focus on set 1 and set 2, and we want to update set 1 where it's the union of the two. So you would do set 1 dot update this time, set 2. Now notice the major difference in the syntax. Here I needed a set 3. Why? Because the union returns a set. Here, notice I don't have any equality. In other words, that is, the result will be stored in set 1. Well, let's go ahead and prove it. So print after using the update method, and we're going to say set 1 is, and we're going to look at set 1 now. I'm just going to type set 1 here and see what happens. And you can see here, after using the update method, this is what we get. Okay? All right, so there's a major difference between union and update in terms of implementation. The idea is the same though, except if you're going to be using update, you're going to lose what you already had in set 1 to begin with, but the product of the union will be stored in set 1. Okay? So what else? So now let's look at the intersection. So let's remove all of this. And we're going to look at the intersection either with update or intersection simply as a method. So to do the intersection with update, let's go ahead and supply it to a third set. Let's call it set 3 equals, and we're going to say intersection. So that would be set 1 dot intersection set 2. Now, let's look at what set 3 is. So this is in its pure form. You're returning it to a set 3. So let's go ahead and do that. And let's see, print set 1. We want to make sure, hey, is set 1 still intact? Is set 2 still intact? And what is the result as far as set 3 is concerned? And let's go ahead and do set 3 here. Let's run this. And there you have it. So the intersect between them is the common value, right, between these two sets. Okay. Let's go ahead and add more items here. Let's say we had 7, and let's say we had 7 here, and let's run this again. As you can see here, we have a distinct sect that has 2 and 7 as the intersect. Now let's do the intersect update, just like we did with the union and the update. In that case, if you're going to be using the intersection update, right? So let's go ahead and do it here. And that will be the intersection update. And we're going to remove set 3. We don't need it. Let's see what results we get. And there you have it. So that gets stored in set 1. Right? So it writes over set 1. So anytime you see the keyword update, either in the intersection or update by itself, you know you need to use that method in this manner without returning a value to a distinct set or a new set. This will simply write over the set that you want, right? Just in case you don't need set 1 the way it was anymore, you're just writing over it and you just want the intersection of the 2, and that will be the result of that. Set 2, on the other hand, is unaltered, so anything you put here as a parameter is not touched or modified. So now let's go ahead and look at the symmetric difference update and the symmetric difference. Okay, so for that, let's go ahead and do the symmetric difference just like we did here. So what is the symmetric difference? So let's see where that is, right? So let's call set 3 equals set 1 dot, and then we're going to do symmetric difference. Notice here you have choice of these two methods. And we're going to tell it with set 2. So I need you to observe now, and you can tell me what you're seeing. Okay, so let's go ahead and print it. Print set 3. We know this will not affect set 1 and set 2. However, we'll get a new set that has the symmetric difference between these sets. Let's run it. And what is that? Well, it's all the values other than the common ones. Which are they? 2 and 2, 7 and 7. Okay? So what if I had a duplicate 6 here again? Let's run this again. And notice it does not take care of the duplicate. So take that in your notes as well. So even though I have a duplicate 6 and 6, in the end, I'm going to end with a distinct set that has a single 6 here. Now we know 6 does not exist on either side. Now if we did, then we will no longer have access to that 6 here. And notice now 6 disappears, right? And that's again a characteristic of the symmetric difference. Now, let's take that out and let's do a symmetric difference update. In that case, you're going to be printing set 1. Oops. Print set 1. We're going to alter set 1. So in that case, you don't need to make set 3 equal to that. And in here, we're going to pick symmetric difference. So I'm just going to go ahead and type dot and symmetric difference update. Okay, we're going to get the same result, except now it's stored in set 1. And there you have it. Okay, on that we conclude the lesson on sets. The next lesson will be on dictionaries. So stay tuned and I'll see you then.